This is lesson 4.1, ionic bonding. So an ion is a charged particle that's formed when an atom loses or gains electrons. And the reason that atoms lose or gain electrons is to get a full octet. So they try to get a full outer shell, which is also called noble gas configuration. Remember that transition metals can lose different numbers of electrons from their d subshells, so they can form multiple stable ions. Exceptions are things like lead, tin, silver, and hydrogen, which only form one stable ion. Polyatomic ions are ions that are made up of more than one atom that together have lost or gained electrons, and you must be able to memorize the polyatomic ion. An ionic bond is formed when metals transfer electrons to nonmetals, and these opposite ions that are formed are held together by electrostatic forces, so the positives and the negatives attract each other. Remember that when an ionic compound forms, the compound is neutral overall, so the positives and the negatives cancel out. And in order to determine the formula, we use the crossover method. So, ionic character can be predicted from the position of elements in the periodic table. Nonmetals are on the left, remember, and nonmetals are on the right, remember, and metals are on the left. So this is a mistake right here, excuse this. And the highest tendency for ionic compounds to form are between elements on the bottom left, which have the lowest electronegativity, and on the top right, which have the highest electronegativity. Remember that ionic bonds are formed when there's a difference in electronegativity of greater than 1.8 units between the metal and the nonmetal. And when the negatives and the positives come together to form that electrostatic attraction, they form a predictable 3D crystalline structure, so a repeating pattern of negatives and positives. And so the negatives, for example, in sodium chloride, the chloride is always surrounded by positives, and the positive sodium is always surrounded by negative chlorines. And this lattice has very strong forces between the ions. And the strength, or the energy required to break those ionic bonds, is called lattice enthalpy. And the lattice enthalpy depends on two things. It depends on the size of the ions and the charge on the ions. The higher the lattice enthalpy, the more stable the ionic compound. The coordination number is the number of ions that surround a given ion in the lattice. So here's a picture that shows just a few different types of lattices with different coordination numbers, and you can see that depending on how many atoms are coordinated, the shape of the lattice is different.